wash tape, and it seal that way?
No, I would not have attempted, unless I was at home. I
I
had a
have done,
conduit coupling. My wife said, I gotta take a shower, and I knew the consequences. If she didn't get what her wish, then I would try and make that conduit coupling work. Other than that,
I have
King
made
Kong
one
was
work.
standing there telling me to use it, I tell him, heck no.
I have made one work. We was 30 miles out in the middle of nowhere, and that's all the coupling we had.
Yeah.
You put enough Teflon tape on it, it'll
Yeah,
seal,
you
but
can make it work and force it in there.
it's not good.
Yeah, your conduit coupling is thinner. It's made to hold, well, there's no conduit in here, as you can see, it's just made to hold pipe together, so you can run wire to it, protect that wire. It's not made to hold any pressure at all. Matter of fact, I was told this, that conduit, you want conduit to breathe, you wanted air in the conduit. So it didn't matter if it was, you wanted it tight to hold together, it didn't matter if it leaked air in and out, because it helped keep moisture out and all that stuff. But anyway, having said that, so when you tighten this pipe up, the farther it goes in, the tighter it gets. Not because you're just running out of thread like on a nut bolt, because you don't have a shoulder here to tighten up on. It's getting tight because of the taper. And then that's what seals it. So remember that anytime when we had this problem out at the plant, and finally somebody got smart, I don't know who it was, one mechanic, one electrician, and they painted the dyes yellow. The dye housing, because people were using the dyes on the machine for one for the other and get them confused. So the electrician's dye has a straight, it's gonna put the thread straight on the pipe. And the dyes for water is gonna put a taper. Okay, soldering joints. Many of the fittings used in piping systems are made of brass, which is an alloy of copper and zinc. These fittings can be soldered into copper pipes. So sometimes you'll see this solder, this joint right here, and we may do some soldering in the mechanical. But the main thing with copper and brass is clean it. You got to have a good clean joint. You got to put your soldering paste on it, get it to the right temperature, get it with the solder. It'll suck that solder into that joint and make a nice good fit. So like I said, a little hands-on on that.
So when you solder copper, do you use a direct heat on the joint? You don't, do you? It's usually above or below the joint, isn't it?
Use it on the joint.
Use on the joint?
I usually put most of my heat in the fit.
Yeah, put your heat on the fit, and you can put it on, start it, just get on one side and stick the solder on top and just suck it right around. If you, the main thing is clean, and after you get it clean it again. I mean, that's the whole idea with soldering. If you do that, it'll make you look like a pro. But if it's dirty, or you got bad paste, your paste is dirty, any impurities, give it problems.
Now, paste you're referring like flux? Paste and flux is the same difference synonymous?
Yeah, paste works like a flux, yeah. Welded joint. If you're not a welder, you don't take a welding class, you probably won't do this. But anyway, this welded joint to a pipe, that's called a saddle fit. Looks like they made like a 45-degree angle out of it. Flange joints. Pipes got to have flanges in them. That pipe right there you see is welded in, and this 45 is welded in. That's what I was talking earlier about your pumps. You know, those two welds can cause problems, cause cavitation, and cause corrosion inside the pipe, cause a leak. Large pipes are commonly joined by using flanges on the ends. A flange is a ring of metal fastened to the end of the pipe and are usually screwed on. They do, some of them are threaded and screwed on. You do the same way as, not the same as welding, but you get the same results. But That's a lot more work, a lot more labor intense, more room for failure. When you have those big old threads inside a big old piece, big old pipe, more, another area to call cavitation and get a leak. So welding is a whole lot better. Holes in the flange allow it to be bolted to another flange. A gasket is usually placed between the flanges to create a tight seal. An example of a flange is shown above. I have a lab like that in the other room over there, and if you're going to mechanical, we're gonna do a torque lab, and, you're gonna put a gasket in there, and you're gonna take a torque wrench and torque it down. That is key, it's very important. If you see these bolts, around the pipe, when you put the pipe up there, you put the flange in, the gasket in, your bolt started, you need to start in a crosshatch pattern. You'd like to start on this bolt right here, snug it, come over here and snug this bolt, come over here and snug this bolt, get his partner on the other side and snug it, and keep doing that and go around, then come back to him and tighten him, go across and tighten him, and then do the same thing around and around.
On the car.
Yeah, just like with a wheel on car, head on car, intake on car, anything like that. You don't wanna tighten. I've seen green mechanics go they grab and start tightening right there and start going around. So, don't do that. Bell and spigot joint. You don't see these hardly anymore. They do, they're still there. There's some companies that still recommend this on their sewage. These pipe are actually put together, and you put that oakum is like a packing down in there. It's like I'm trying to think of the material name, but it's high, it'll take a lot of heat. It's not like, it's a fiber, but not really fiberglass. Anyway, you pack that down in there, and then you take lead and heat it up in a pot. You melt that lead down, and you pour that lead in there. So these joints have to be standing up. You have to do it, stand them up, put together. If they're laying down, they make a apparatus that goes around them, that you can pour that lead in where the lead will go up in there. You won't ever do that. If you do, it'll be very strange. Groove joint. These joints are used, and you might see these, especially on temporary piping, like, let's say they got a pond out there, and rains comes, and they need to get the water out, or maybe, like the mines, the Kaola plant, I mean, we dig a hole here, and it stay there for 6 months, and cover it up, dig a hole here, there. So we had temporary pumps, sump pumps. And we use a lot of this piping right here. And if you look, the pipe has grooves cut in it, right there. And like right there and right there. And this clamp goes around it and sits down in those grooves with a rubber seal right here that seals the pipe. And if you look closely, you see how that seal works? You see it's open right there? Actually, the fluid will go up in here and pressurize that seal, pushing those lips down on the pipe to keep it from leaking.
So
It works great.
more pressure to tighter the seal.
Yeah.
Concrete pumpers use
Yeah,
those a lot.
concrete, you use that a lot.
I couldn't see that little groove.
Yeah, that groove, that's steel pipe,
Very small.
and that groove's actually cut in there with a machine, like a lathe, but it's, you can, like, your bolts on there and it cuts that groove in there. We use aluminum pipe a lot, and it had what we had a groover. And you stick that aluminum pipe in there and clamp down on it and spin it around, and it just pushed, it indented a groove in the pipe. You can stick that pipe together, and it'll sit there and move. I mean, it has, you can move it, you can put it in and curve it, because it has a lot of flexibility in those seals. But it's not gonna go any farther than the groove will let it. So, it's a good setup. Plastic pipe joint. Plastic pipe joints are the easiest joint to make. The ends do not need to be a special shape. Plastic connectors are made to fit over both ends of the pipe and that are being joined. A special plastic glue seals the pipes together. See above figure. This, they're showing two things too. These are put together with two rubber couplings, clamps. Those joints are glued. Remember this, you got, I don't know if it's gonna touch on, all right. You got, in your household, you have PVC and CPVC. They're not created equal. You do not want to connect one to the other. And then again, unless it's the weekend and the wife's gotta take a shower, you got, I mean, that's, but,
Wow.
and there's different glues for PVC and CPVC also, which is, I've seen that, not, I guess not so critical, because I think both one used for the other with success, but I would suggest, if you put something in your house, it's gonna be permanent, get the right stuff, recommended stuff. When you're joining PVC or CPVC, do not use sandpaper. Never use sandpaper to clean your pipe, you join. Because the whole idea, when you're joining glue and pipe together, the glue is not a glue for, say, like Elmer's glue. The glue causes a chemical reaction with the pipe. It makes the pipe get hot and it melts the pipe together. So it's really not the glue that's holding the pipe together.
It's the reaction.
It's the reaction. So it's got to be a close tolerance. If you sand that tolerance away, that reaction is not enough reaction in there for it to seal. So clean it with cleaner or a primer. And the primer, and you can get by without primer, but it's a whole lot better. Use the primer, clean your pipe with it. The primer actually starts softening the PVC a little bit. And then when you put the glue on there, you put it together, it's just a better fit. I have used alcohol, rubbing alcohol, because I didn't have nothing else to clean the pipe with. That works pretty good, but it doesn't soften that PVC. So, when you glue and fit together, make sure it's clean, but don't clean it with sandpaper. We actually learned that hard way. Yeah, we would put the pipe together out at work. And had them, we don't need primer, we clean up sandpaper, stick it together, and it stick together and leak like seal. Go back, we pull it apart, sand it some more.
It'll work. Stop.
So we find out, oh, wait, so,
Something ain't right.
well, you know, nobody really, and I'm talking about years ago, nobody really gave us a class and told us this kind of stuff, you know? We thought we were doing the right thing. We blamed it on the glue. Compression joints. You'll see a lot of compression joints used in, air. You see it in air and hydraulic, well, not really hydraulic, because high pressure. Sometimes you'll see a compression joint
Dishwasher.
hydraulic. Most of the time hydraulics is flared. But, these are, like copper lines. This little compression nut of ferrule. They call it a sleeve, we call it ferrule. You see this nut right here, you see the shape of the sleeve, it's over the pipe. When you tighten it, these angles right here, these tapers, this little sleeve is actually soft, it's made out of a soft copper, so it squeezes it against the pipe. And it's permanent, it's not a temporary thing, unless you didn't tighten it tight enough. But if you squeeze it down tight, it's gonna stay on that pipe, and it'll, only, if you mess the threads up or something, come back out, if you got lean, you won't have to cut that pipe off and start again. But, compression fit works well, they're a little aggravating, sometimes they're hard to get lined up, started and everything. They're not perfect, they don't take a lot of angular misalignment, you need to be pretty straight with them.
They don't take vibration or movement well.
They don't like vibration or movement either, no. A lot of times they'll break that pipe right there. Welded pipe fitting, okay. That's that's a 90 elbow, a 45, a 90 reducing, cause that's going from one size to another. 180 return, don't use those a whole lot. Reduction tee, it's one side right here, different size there. Straight tee, that should be the same size on both sides, but it don't look like it. Cross, a reducing cross, two different sizes. A lateral, which some people call it a Y. A reducer, that reduces from one side to the other. A cap, and a plug. Now, why would you want to use a cap instead of a plug in certain applications? A lot of times, if you use a cap and it's in water, you ever hammering, you ever been in a house and the pipe goes, well, actually, if you have that rounded edge on there, and if it has a little air pocket in there, you can prevent that.
Really?
Yeah. And a plug would probably do the same thing. It's like better results with a rounded cap. That's just a plumber told me that. But I was plugging, gonna use some plugs on some pipes in my house. He's told me to use caps. Remodel the bathroom. We were looking at this earlier. Lines for piping drawing, general piping, identified by material carrier. Yeah, if you see a drawing like this, and it's an acid line, it should have acid wrote on it, because that's critical. You know, it shouldn't be just, you have to guess, oh, it looks like the line for acid. You need to know it's acid. Non-intersecting pipes. All right, y'all remember yesterday I showed you they're doing that a little different right here. Make it a little bigger. They just come in here and stopping. Where I showed you yesterday, I've done like this. Air. Got an A in it. Cold water is a long dash, a small dash, long dash, small dash. Steam, straight dark line. Gas is gonna have a G in it, just like I was saying about the acid. Hot water is a long line dash dash, long line dash dash. All right. Condensate is equal line, dash lines. Fuel oil is marked. Vacuum is marked with a V. Refrigerant is marked with RL. So, that's the way it should be. Then again, like I said, like the drawing, this is not standard. American National Standard Institute does not mandate that all of them have to be the same. So, you can see variances in these drawings, these symbols, graphic symbols. Double line drawing of a pump station. This right here would be well loved by a contractor who's fixing to install this pump station. But he rarely ever gets a drawing that looks like this. It's mainly just a, come over here and look at the dirt. I want you to put that right there. And you have to take a piece of plastic around when you cover the draw up so the rain won't wash it away. But this is a pretty good drawing of the pump. You know, I mean, it's a pump. It's got a suction valve coming in, the suction, drawing suction valve. You see the two valves going out? Why do you think they would have two valves in there on the discharge?
Isolate that motor or that pump?
Well, evidently, the way what this is, what's going on here is that's a
Return,
very,
let's have a return come back around.
very dangerous material.
Mm-hmm.
You got more
And
than one
when
cutoff.
if if you close that valve off, that's the only valve, let's say that's the only valve in the line, you close it off, you remove this pump for repair. You got one valve between you and this pump pumping that. So, they put two valves, we've done that a lot, put two valves in there, it's basically safety reasons. But,
But you could cut it off at either valve, right?
yeah, you cut it off at either valve, but you can cut it off at both to remove the pump. Single line drawing of a pump station, this you would get instead of that. So, which is telling you the same thing. You just gotta know how to read something, you know. Motor, pump, valve, flange, that's gonna be a check valve, check valve right there. So the check valve, it's a flapper check, a flapper check, there's a flapper inside the valve. Inside there, there's a disc right here. The flow can go this way, when it comes this way, that disc slams closed right there. And stop the flow from going backwards. There's several different kinds of check valve. The flapper valve is the most common. That is a flow control, like a flow control valve to me. Right there. Strainer. The figure above shows a single line drawing of a pump station. Take notice that the valves and fittings are not easily recognized, yes, unless you know the meaning of the symbol. Even though you can see the layout of the station more clearly due to the fact that the less important details are not shown. As an example, this drawing doesn't show the flange bolts or the shape of the handles on the valves. But that's the thing too, this drawing right here, so that valve right there, that symbol could be any of 20 valves, butterfly, you just don't know, they don't tell you what kind of valve. At least this one, here, you know it's a gate valve, I'll get right in a minute. You know that's a gate valve, and it's with a screw type handle, it's not a butterfly valve, so at least you kind of know by looking at that drawing what kind of valve it's going. Isometric drawings of a pumping station. Same thing. Just practice. Yeah. Joining metal pipes. It is not difficult to join metal pipes and fittings. Unfortunately, under certain conditions, the joints you create today may cause failures months or years on down the road. These problems can be avoided though. Care must be given to not join two different kinds of metals together. Like I said, care to be given, but you can join two different types of metals together. Sometimes, we had a couple situations out in the plant where, it would start off stainless and then when it got so far, it'd go to black iron pipe. Because your reactivity was more critical, like right after the pump. The chemicals was put in, they hadn't mixed real well, but once they got outside the plant, in the tank farm, what we call where the tanks were, they might change it from stainless to steel. Care must be given to join tight together. Some metals when joined together can cause corrosion. The same problem can occur when attaching metal supports. An electrochemical reaction occurs when two different metals come in contact with each other. This is called galvanic reaction. One of the metals start corroding, usually caused by combining with oxygen. The other remains protected from corrosion. Galvanic reaction, we had that, the pipeline, when we had steel pipelines from 6 miles from the mine to the plant. they got plastic now, so it's not a problem. But there was a wire run on top of that pipeline that sent a little bit of electric charge into that pipeline, prevented that, galvanic reaction. So, let me show it. But anyway, that was a way to prevent that back then. So like I said, they, took care of that problem with plastic pipe. Another thing too, if you have any boaters out there, you notice on the foot of your boat, there's a little piece of zinc, is zinc, it's mounted to the foot.
Head north.
Yeah, yeah.
What?
That little piece of metal attracts the galvanic reaction. It, instead of it reacting to your aluminum on your foot, on your motor, it goes to that little piece of metal there. And that's why you'll see, one of my pontoons, it's eat up pretty good. And you don't ever have to replace it until it's gone. I mean, as long as it's still there, it's doing the job.
They put them in water heaters too.
Yeah, water heaters too.
You get more reaction to salt water too, with fresh water on the boat.
Yeah, yeah, salt is actually a good conductor of electricity.
Got five on there.
Yeah, they say like people used to throw the toaster in the bathtub with them. They said that when the water doesn't carry the electricity, it's the salt off your skin.
Skin.
Really?
All right, difference in electrochemical.
Water itself is a
potentials.
non-conductor.
So memorize this as a test. The above table shows us that you should never use a brass, bronze, or copper fitting on galvanized piping. Corrosion will set in when copper and iron are going together. And that is very true, because I've seen problems with, in a house, you come out of the hot water heater with copper, and then they screw it, use a iron fitting to connect it to the CPVC. And that happened in my house. We come home one day and it was flooded, and it was in that, where that joint was.
They make a union
How can you see
especially
that on
for,
the table? On the,
Pardon?
how can you see that on that table?
How can I see that on the table?
Yeah.
How do you read the table, what's it at?
Yes, thank you.
I want y'all to take that
I
one.
speak New Zealand.
Yeah.
All right. Protected metal, corroded metal. Potential of metal, that's the potential grade of metal A, copper, lead, tin, iron, zinc, aluminum. I guess that's resistance, I'm not sure.
So if we will take lead, what can I combine lead with?
What's that now?
What can she combine lead with?
Lead,
With lead.
with lead.
And anything else?
It come more closer to combining with iron.
But how can you see that?
Lead and tin,
Yeah.
lead and tin, you got
I couldn't tell
solder.
you. I couldn't tell you, that's why I was telling you I'm gonna do a test on it.
Okay, in this case, copper,
I tell you from experience.
but there is a question in the cast. What kind of metal is used in making fittings that can be welded to copper piping?
Brass.
Brass.
brass is the only one.
That's
that
from
you
your
can-
experience or you
That's
can
from
see on the
experience.
table?
It was
That's
on
from
the-
That was
experience.
that was
No,
in one of the
actually it
earlier
was-
slides.
Okay.
Can I just add lead brass?
Where was that at?
Hang on, I was looking.
It was in there.
It was near the top. Here it is right here, the slide 4.
Right here?
4. You got 6. One more.
Where's the number slide?
Right there.
I can see it. There we go, okay.
That's 4.
Bend fittings used in bend piping systems are made of brass, which is an alloy of copper and zinc. These fittings can be soldered to copper piping.
Okay, thank you.
Good question. I mean, I just wanted to let you know, I didn't know how to read that table either, I've never, and
They do make a union that you can connect copper with iron pipe. It's called a dielectric union, but they're not real cheap.
no, imagine
And
not.
they have a rubber seal in them. It separates the
Separate.
two.
So
that rubber over time, you end up with a leak anyway, so
Yeah.
So it keeps it from corroding.
it keeps it from corroding, but
it's
you still got
rubber
that,
seal to
mm,
wear out.
it'll get wore out.
Post?
That last one, yeah.
Doing post.
It ain't, it's not doing the ding ding. Come on now.
I kept
Be
volume
consistent.
down on you.
Uh,
No, I'm just kidding. Said I
you
cut
changed
volume
it.
on, but I didn't. I don't know why.
Okay. Well, wasn't that interesting? That was interesting. I just didn't wake up sleep. Oh, nodding a little bit, but it's leaving sleep. Believe me, I'm trying my best to make it interesting. I know what, how it can be. You know, if there's nothing else, if you, something you can take home with you, I'm proud.
Teamwork.
You use it home.
Break time after post.
We gonna start 30 minutes ago. Jimmy Cricket.
We had a test. Come on.
Two of them.
How many people you know take two tests on
We gotta find a safe space sometime.
Oh, no. You didn't say that to me. I know you didn't say that to me. Safe, baby.
That was a good one.
Go find you a puppy.
Nice.
Huh? Yeah. Think about it. Plywood,
Yeah.
you just got two components. Nothing to do.
Why? Why did I do that?
The one you missed the first time. How'd I do that? I need to look at a question. Need your help. I need to look at something, I know I answered it right. But
He
it
said
said I
he's not a
did.
psychiatrist.
Huh?
He said he's not a psychiatrist.
No, I mean, I got 100 the first time around.
I'm not a miracle
I
worker.
think what happens is how you roll your how you scroll down, I think it moved my answer, cause I got 100 on the first one.
That's happened to me about 5 times, so I'm gonna get back to you on mine.
That's why I use that one to slide and scroll.
As long as you,
That's why I didn't do that.
if you like, yeah, if you
I
like
need
click right here,
I got
just click
a
off of it,
Think
where you got a little.
Got me out here.
He's right here.
Probably not.
You had 100 on the first one?
Yeah,
Then why'd you take it to?
Yeah.
you've been telling us to.
Yeah,
You've been telling us to, haven't you?
yeah.
I tell you to take the post, but I didn't, not if you have 100 on the pre.
You hadn't said that.
Y'all didn't ask me. I've had some to ask me.
Okay, now, all right, I made 100 on the pre, so you gonna exempt my 90 on the post?
I had one of them yesterday, I made 100 on the pre and an 80.
But he hadn't said anything.
But really, you think about it, if you make 100 on the pre and you go make 80 on the post, I really ought to give you a 60.
That's all right, I'll keep my, that's the reason I didn't say nothing, I keep my, it was my fault I made that.
Everybody got a reply.
I know what the answer was.
I got too big of a hurry on it, that's the reason I
But
made
no,
that.
if you make 100 on
I
the,
scrolled.
That's
when
what I
I
was
shouldn't
talking
have.
about.
if you make 100 on the pre,
I did the same
Don't
thing.
take
I made
we
a-
gon' you don't have to take a class.
80-something on the.
Are you
Still
gonna
gotta
give
sit
me-
through the class.
Okay, that's fine, can I get credit?
Yeah, I done that the
I
other
think I
day,
did
made
the
like
same
a
thing he
90
did.
something
I
on
think
the
I
three,
just
and he
scrolled.
took the post and missed another, made 85.
See, that's what I'm talking about, I'm gonna give you 60.
But it'll be all right.
I'll tell Lee, he'll probably get a second. All I did, my idea is just to teach you something, nothing.
That's right, that's why I sit through here. I mean, I still
I'm not
make-
gonna hire you. I'll tell you right now, I'm not hiring you. That's
You don't
Val-
like
that's- That's Valmira's job. I can't afford it.
Oh,
So I want you to learn something. If
I wanna
you
go to
want
work with you.
Valmira or
I
something
wanna
like
go
that,
work for you.
you cut that thing off. You cut that off.
We did too. No, he didn't. Handle there or other gases, whether it's hydraulic or pneumatic. There are 5 elements in any fluid power system. Reservoir stores the fluid used in a hydraulic system. In a pneumatic system, the storage device is called a receiver. Pump. For a hydraulic system provides flow and pressure for the system. Pneumatic systems use a compressor. Keep in mind, you can compress air, but you cannot compress a liquid. You cannot compress hydraulic fluid. You do, try to, you're in trouble. Actuator. And I tell my students at school, go home and do this, they won't do it in front of me because it looks stupid. When you try to compress, we're talking about compressing air, puff your mouth up and try to hold air in as long as you can until it comes out of your mouth. And that's actually how a compressor is working. And you can actually pump enough air in your mouth that you can't hold it with your lips unless you've got lung problem. So that's just a little way you can say to get an idea of how compressed air works. An actuator for either system, the device that reacts to the pressure and does the work. Valves direct and regulate the flow of pressure. They are connected to all parts of the system. Piping, the lines that carry the fluid in a hydraulic system or pneumatic systems, they're called tubing. Symbols for reservoirs and receivers. Remember, the reservoir looks like a tank and it's open. That little symbol's gonna be open. This one is showing it closed with the top on it. And it can be, but basically when you see those drawings we looked at earlier, you're gonna see this open part like that. The pneumatic receiver is gonna be a oval shape, look like a capsule. It's enclosed, so it's a receiver. It's holding compressed air. Symbols for compressors and pumps. Fixed displacement pump, compressor, variable displacement pump, compressor and hydraulic. A single acting cylinder.
Spring.
See that spring up in there? That means I can put fluid in here, push that out, and when I open the valve, let the fluid out, the spring's gonna push it back. Single acting. The piston in the cylinder, force on the piston rod. The symbol. Okay, I don't know if this slide touches on it, we're gonna touch on it right here. In this cylinder, right here, let's take the spring out, okay, we're gonna say this is a double acting cylinder. Which side of this cylinder can I get the most pressure on?
Left side.
This side or this side?
Left side,
Okay, left side, why?
because the rod's
You gotta
pushing.
counteract that spring.
Well, the rod's taking away from the amount of volume you can put in the cylinder.
Exactly. All right, when you talk about, I'm putting 10 PSI, 10 pounds per square inch in this cylinder here, and I got 4 square inches, okay?
Right.
But when I get over here, I can't get 4 square inches because my shaft is taking up 1 inch, so I got 3 square inches. So your cylinder's a lot stronger going this way than it is going that way. Just keep that in mind.
So it's opposite.
Yeah,
Is that what
it's-
you're saying, is to the right, you get more?
yeah, that particular cylinder going to the right is a lot stronger. Even in this cylinder with the spring in it, but this is, the
that's
spring
good
is
to
the
hear.
only power on this side of the cylinder. But on a normal cylinder that has the inlet on both sides, you're gonna get the most pressure on the back. It's gonna be the strongest. That's like a log splitter, works pushing out.
Or a front end loader on a tractor.
It also has to do with
Yeah.
the area of the piston itself.
So any configuration you can get where a cylinder's doing the work as it goes out. And some cylinders do the work coming back in, like a shear. You know, a shear that shears metal, most times it's got a big hydraulic cylinder on it. They got an arm come over and it gives it leverage. And that leverage enables that cylinder to, instead of having a giant cylinder this big with a monstrosity of apparatus above it pushing down to shear that steel, you put a small cylinder over the side and use leverage. Cylinder here. Cutter blade for your steel right here. This cylinder will actually pull down on this leverage. If you didn't have that leverage right there, that cylinder, it wouldn't do. There you go. Should have went to the next slide. Double acting cylinder. You see the shaft is taking up space in that cylinder, so you have less area for the fluid to push the piston. There's your symbol, it's got 2 marks on it. And go back to this one, I told you earlier you would see a spring. You can see this one has 1 inlet. So that still means it's a single act. Or you will see it with a little spring in it. Pressure acts on total area of piston. Pressure acts on part of the piston. That's what I'm saying why the force is different. Double end rod cylinder. This has a rod coming out both ends. It's doing 2 different things.
You're gonna get the same strength either way.
You're gonna get the same strength either way on those, yeah. If you got the same fluid going in. And that's the symbol. Symbol for the double end cylinder. Okay, a rotary actuator, which is, I call it hydraulic motor. Fluid goes in, come on now, you gotta have outlet.
That's what I'm saying,
Yeah.
gotta have outlet.
That's
I
what I
think
was
they
wondering
just,
on
I
the
think when
next
it's supposed to
slide.
be the outlet, they just wrote.
Yeah.
Well, most of them you gotta forward and reverse, so either one could be an inlet, either one could be an outlet.
Yeah, if you got a forward and reverse, most of them do forward and reverse, so they may be right calling them
Yeah.
inlets. But what you have is fluid going in, fluid going out, your little manual man pulls back, and the fluid starts coming back this way and goes down. I have one on a trainer, you can sit there and go back and forth.
So you're saying,
That is the motor on my zero-turn motor.
so you're saying cycling it left and right, it's gonna either pull and push?
No,
Yeah.
it pushes both ways,
Shaft to the right. or
but it just,
to the
it
left?
changes one inlet to an outlet.
Yeah, that's what I'm saying, so
Yeah.
it's pulling in and pushing
All
out.
right, let's back up.
That's
Now,
what?
erase what I just told you.
Both of them are pushing. Just
Right,
one at a
this is an
time.
actuator, this is not a motor. I've got to help myself. This is an actuator. And that's right, this is an inlet, and That's a stop. This is not a motor, I'm sorry. This actually, the fluid pushes this is an actuator that may be opening and closing the valve.
Okay.
Left, right, left, right, left, right. And that's a stop. That's why they call it inlet. Fluid will come in, it'll push this the vein around. This is attached to a valve or whatever, and it opens that valve, then you send hydraulic power back, and it pushes it back around.
So the
Basically
stop
works the
stays,
same way, it just don't go all the way
Yeah,
It
around.
just don't go all the way around.
Right.
yeah, the
So it's
stop
only go
stays
forward.
stationary and
Right.
then the
So it
van
only
and
goes
see
so
it
far
move,
and it's
okay,
not.
Okay.
I got you.
You probably won't see many of these, but they're used.
That was my next question was, what's the difference between the stop and the vane and seal? The vane and seal, you moves and the stop stays stationary.
Right, stop, stay stationary. Your motor symbols, pneumatic motor, this is, I hope they show motor there. No, four-way, three-position valve. This is your different valve, don't get too caught up in that, because those valves go from anywhere from single acting two-way to 26 acting 72-way. I mean, they can get on up there, so. But main thing you need to know is you see that little spring right there? The spring actuated button, there's a button. You push that button, it'll do a certain action. When you turn it loose, the spring's gonna come and pull it out, push it out, and it's gonna do something else. So it's a action. Like I say, don't get too caught up in that, because it'll drive you crazy. Developing the symbols for four-way, three-way valves. This can also get complicated, but it's, like I said, just remember the basics I showed you earlier on the valve, on the symbol, the difference in the direction. This one is spring loaded. This, the spring pushes, when it has a spring on both sides,
Spring center.
the spring center. So you put it to the center. That's a solenoid, and that's a solenoid. And this, can also be a manual configuration, where when you pull a panel like this and turn it loose, it goes back to center. A wood splitter. It's spring actuated, pulling it back this way, so when I turn it loose, it goes back to center. But when I push it back, it stays back until the cylinder goes all the way back, or I pull it back.
Like the hydraulic controls on an old tractor.
Yeah. Symbols. If you start, work at Valmir or somewhere and you're gonna be in the maintenance department, they hire you to maintenance shop, go to Google, pull up all these symbols, make you a notebook, put it in your locker. Or sit on Google and memorize them all. We're not gonna do it here. But, you can pull these up and print them out and have them readily available. Like, I have a big cork board in my lab at Sandersville, and I got them all over it. And the students will go to them, I'll make them go to them, and go find certain things and get the references. Okay, that's it.
All right, there's still a question that it didn't answer in that slide, and that was the four ways that a valve can be operated. Was not in that presentation.
Is that the only one?
Yeah, the other one was
The other
answered.
ones are answered. So I wrote down all the questions and then
That's the one I was waiting for right there. And that answered one of them right there, but the other one didn't get answered.
I guess that's a good thing.
What is it? Four ways to reach Bob's. Look what it is.
It's in the table of,
Okay, two.
electric valve.
That last one, by hand. Now it ain't reading.
By hand and lever, those are the same. By hand, mechanically, electrically, a sensor is not gonna operate a valve. By remote, mechanically, electrically, self-actuated. You're not gonna operate a valve by remote. Although it's possible, it is possible. And by hand, mechanically, and electrically, self-actuated. It wasn't explained in there.
No, what?
I guess I can see it when I don't see the choices whenever I do that.
Which one you want?
Start post.
It is in here. Yeah. Keep on.
Which one
I
is
bet it
it?
says method, it's on one of the diagrams, and at the bottom it says methods of control.
Which diagram?
14, go to slide 14.
One way says spring.
One of them that you couldn't read.
Self-actuated.
One of them that
So
you
what
can't
does it
read.
say spring?
Yeah, what you have?
Which slide?
Yeah, that's what the answer to that one was in there where you can't read it.
Which slide?
Slide 17, I think is what they said.
17.
14.
You can't read that.
Wait,
Oh, I'm
you-
sorry. That's fine.
What's the question?
Without zooming it way in, it's gonna be down at the very bottom of that.
That's
I guess you're saying like, when you introduce pressure, it opens, and you take away the spring closes.
Yes, that spring manual pilot, and see, those aren't,
That one
Oh,
is
you
valve
change the
control,
slide.
that is pressure. Pressure control.
Self-actuated is, the spring operates the self-actuation.
Mechanical.
So that means
Valve,
spring
yeah.
means self-actuated, yes.
but see, and then you got pilot operated, wouldn't that be by hand?
Cylinder.
No,
control,
a
still
pilot
mechanical,
actually operates the
electrical
self-actuated.
motor,
So that would be the left.
Spring, manual, pilot
So pilot
operated,
is
and electrically
self-actuated,
operated.
can be changed.
Pilot operated is pneumatic, isn't it?
Which name?
Yeah, mechanically,
I guess that's technically
mechanically would
mechanical.
be the spring, by hand would be your hand.
He showed us the answers, I put it.
Electrical would
Spring
be
is
on
what
cylinder.
self-actuated then.
Self-actuated would be on.
That spring
pilot.
is
The pilot, okay. So pilot is self-actuated, spring is the.
well, they can't say it wasn't in there. It was.
Yeah, it was in there, you just couldn't see it. Wasn't unless you blew it up.
Yeah, it's like the fine print on,
Yes,
Yeah.
you're the only one to see it.
It's like agreeing to the terms of service with Apple. You don't never read it, you just do it.
They call it fine print.
Because if you ever read it, you'd be there for 4 or 5 days before you got through reading.
and you won't understand a word it says.
Nope.
About like financing a car.
Yeah. Yeah, where I didn't see that fine print, they were gonna sell my loan to another company.
Yeah, just sign here, sign here.
Then I ended up refinancing it again.
They don't even want you to read it. We got sticky tabs and everything you need to sign.
Yeah, for a cheap rent.
What
And
is
you get to skip
just
them
chapter
for more.
19?
We're gonna come in and do some videos.
Y'all quit talking about me.
Things I think maybe you can use more of there.
The page
But look,
one,
that-
chapter 11, we'll do that one.
No, we're not gonna do, we're not gonna do any more than do magic. But look at, y'all look at it, and go over it. It's not gonna hurt
And I
you.
can take 3 minutes.
Grace of God in heaven gave me 100 on it.
That's what I'm talking about.
We all just say,
You won't take it.
I'm not questioning
we
it.
all just say it's posted.
Yeah, we